Hey everybody. So in the last lesson, we were talking about going from translating words into an equation and then solving some simple one-step equations. Today, we're going to actually get into looking at two-step and then multi-step equations after that. But I want to make sure that we go from one-step to two-step and then get into some of the more difficult problems and work our way up. So even though this is more than one step, we're still thinking reverse those order of operations to get our variable by itself. And remember, our order of operations was PEM DAS. So we're thinking undo the order of operations, reverse. So in this problem here, anytime that we're solving an equation, we're going to set it up with a t-chart. So we've got 4x plus 2 equals 10. And now I'm going to go through, okay, I need to reverse my order of operations. So first, I need to try to get that x by itself. Since it's on the left side, I want to leave it on the left side. So I want to keep it on the left side, move all the numbers over to the right side. So the first thing I'm going to do is I'm going to undo the addition and subtraction that's attached to that variable. So there's this plus 2 that I need to get rid of. So plus 2, how do I reverse that? Well, undoing addition, I have to subtract it. So I'm going to subtract 2 from the left side. The whole point of the t-chart is whatever you do to the left side of the t-chart, you do to the right side of the t-chart. 2 minus 2, well, that goes to 0, so those cancel out. So I'm left with just 4x on the left side. On the right side, 10 minus 2, that becomes 8. From there, this is just, so we went from one step, now we're in another one-step equation. 4x equals 8. What's going on between 4 and x here? Anytime you have a coefficient in front of a variable, that's multiplication. So to undo, to reverse that, I need to divide by 4. Once I do that, 4 divided by 4, that goes to 1, so I'm left with just 1x, or just x, equals 8 divided by 4. That gives me positive 2. So my final answer in this one, x equals positive 2. And it's always good to go back and check, make sure that works in your problem. 4 times 2, that's 8, plus 2 equals 10. That is a true statement. Because remember, the goal here is whenever we have an equal sign, we're saying that that statement is a true statement. And we're trying to figure out what are we missing in the statement to make it true. In this case, we're missing 2 because 4 times 2 plus 2 gives me 10. If you got something where it was not the same on both sides, then you would have to go back through, check your work, see if you made a mistake somewhere. Okay, second problem here says to solve for y. So y is up here in the fraction. We've got -3 equals y over 4 minus 4. First step, we need to make our t-chart. All right, from there I'm thinking reverse the order of operations. So I need to reverse addition or subtraction that's attached to the variable. Well, my variable is here. We've got this -4 attached to it. So how do I undo subtracting 4? Well, the reverse order of operation would be to add 4. And the whole point of adding 4 is so that this term over here goes to 0 and cancels out. So I'm left with just y over 4 equals, and then you got to be careful here, -3 plus 4. That's the same thing as 4 minus 3. So that's going to get me to 1. Now I've got 1 equals y over 4. When you have a fraction, think about what that line in between the fraction actually symbolizes. It's not only separating numerator from denominator, that fraction is actually signifying division. So to undo that division, to reverse division, we have to multiply. So we're going to multiply both sides by 4, so that way we get rid of the denominator. 4 times 1 is 4, and we're just left with y. So y equals 4. It's okay that it's on the right side, and if you want to, you could even flip it. You could say y equals 4. Those are the same statement, because an equal sign, you can flip the whole side if you want to. So y equals 4, that is my final answer. Go back through, check to make sure it makes sense. -3, is that equal to 4 divided by 4? Well, 4 divided by 4 is 1. 1 minus 4, that gives me -3. So that answer is correct. 1 minus 4 is my answer. Okay, so now we've gone through how to do it in 2 steps, and that's going to be the basis for how we solve multi-step problems. We want to get it down to where we can solve it in 2 steps, but before we can do that, we have to do some simplifying and rearranging. So in this problem, we've got 3 times the quantity of x plus 2 equals 8 plus 6x plus 1. So there's a lot going on in this problem. But once we simplify and rearrange it, you'll see it's just like solving a 2-step problem with some combining like terms, distributive property thrown in there, and rearranging before we get there. So again, first thing that we're going to do is we're going to make our t-chart. Anytime that we have an equation, I want you to be making that t-chart. So I'm going to be writing the steps on the side here in green. So step number 1 is t-chart. Step number 2, it's going to sound a little bit weird, but we'll go through it, is going to be simplify expressions on both sides. So this is going to be very similar to how you've been doing it in the Delta Math assignments for Chapter 1, where you had to simplify expressions. Remember, an expression is just a bunch of terms together. An equation is when you throw an equal sign in there and you have that truth statement to it. So that's why we use our t-chart, because what we're going to do is we're going to simplify this expression, and then we're going to rearrange it some. So on the left side, if I want to simplify it, I got to use the distributive property. So off to the side down here in my little scratch work bubble, I'm going to make my rectangle 3 times the quantity x plus 2. 3 times x is 3x. 3 times 2 is 6. So on the left side, so far I've got 3x plus 6. And then I'm going to check to see, okay, is that as simplified as I can make it, or can I combine like terms? In this case, that's as simplified as I can make it. So now let's look to the right side. On the right side, I don't have any distribution that I have to do. But what I can do is combine like terms, because I see this 8 here and this plus 1 here that I can combine to 9. I can't do anything with this plus 6x yet, so I'm just going to leave it as plus 6x. So now I've got 3x plus 6 equals 9 plus 6x. All right, so we've done step 2. We've simplified as much as we can on both sides of the equal sign. So now we have to move to step number 3. And step number 3 is just going to be to rearrange to get all of our x's on one side. So rearrange to get x's on one side. And the reason why we're doing this is because we want to get it down to where it's in that 2-step problem format, where it's a coefficient, a variable, plus another number equals another number. And you'll see what I mean when I go through and do it. So one thing that I like to caution students on, or one tip that I have, I should say, is when you're moving your x's around, it's a good practice to try to move the least number of x's that you have to. So I'm looking here, I've got 3x on this side, 6x on this side. And I want to move the least amount of x's that I have to. So the least number of x's would be this 3x's. So I'm going to move these 3x's. So I have to think, okay, if I want to get rid of this term in this expression, how do I undo this term in this expression if it's attached to this plus 6? Well, I have to think, how do I undo adding 6 to it? How do I undo adding 3x to this 6 term? And I undo that by subtracting 3x from it, because then I'm just left with that positive 6. And whatever I do to this side, I have to do the same thing to this side. So I'm going to subtract 3x over there. The whole reason I do that is because now on this side, 3x minus 3x, well, that goes to 0. If I have 3x's in this hand and then I take them away, I'm left with 0 x's right there. So on this side, I'm just left with 6. On the right side, you can see I'm left with 9, because 9 is not a like term to this one here, because this one has an x and this one does not have an x. But I can do 6x minus 3x to get 3x. So now it looks just like that two-step equation we had in the previous problem. We've got a number is equal to a number plus a coefficient in front of a variable. So now step number 4 is going to be solve two-step equation. All right, so we did our t-chart, we simplified on both sides, we rearranged to get it where it's in a two-step equation format, and now we're just going to solve it like it's a two-step equation. So same thing, how do I get rid of this plus 9 on the right side? To get rid of that term, I have to subtract 9 on the left side, or on the right side. Because I have my t-chart, I have to do that on the left side. Get rid of it over here, so I'm left with 3x. On the left side, be careful, 6 minus 9, that's going to give me a negative 3. Now I've got 3x equals negative 3. To get rid of this 3 here, remember there's an invisible multiplication sign, so I've got to divide by 3. And I get x is equal to negative 3 divided by a positive 3. Remember, a negative divided by a positive makes the entire thing negative. So I'm left with x is equal to negative 1. So in this one, we went through, made our t-chart, simplified on both sides. Number 3, we rearranged to move the x's to one side, and then we solved it like we would a two-step equation. All right, going to go through one more kind of more difficult problem just so we're all on the same page here, and so that way you have another example in your notes for when you're practicing on your own. So we've got 3x plus 4 equals 6 times the quantity of negative x plus 7, all subtracted by 1. So I already went through and put my t-chart in, so that way it was a little bit clearer to see. Second step, I'm going to simplify the expression on both sides of my t-chart. On the left side, I already have it simplified because there are no like terms, nothing that you can do with that. So I'm just going to rewrite it here, 3x plus 4. On the right side, I see if I have a number outside the parentheses, that's where I have to distribute. So I'm going to make my little bubble here again so that I can do my scratch work. 6 goes here, negative x plus 7 here. 6 times negative x, this is where you got to be careful. Negative x, that's actually like a negative 1x. So 6 times negative 1x would be negative 6x. 6 times 7 would be 42. So then from here I've got negative 6x plus 42, and I've still got that minus 1. So then I actually have to do one more step here to simplify, because I got to combine like terms. The left side stays the same. The right side, there's nothing I can combine with that negative 6x, so I'm going to leave it negative 6 plus 42 minus 1. So 42 minus 1 is 41. Now I've got it simplified where there's no more like terms, so I can move on to step number 3. So step number 3, I'm going to rearrange to get my x's on one side of the equation. Doesn't matter which one you move. I recommend moving the least number that you can. This one, since we had the x's on the right side on the last one, I'll move my x's to the left side. So if I want to get rid of this term here, this negative 6x, when you're getting rid of a whole term instead of just a number, we want to look at, okay, how is it attached to the other terms? In this case, it's plus 41, so it's attached through addition. So how do I get rid of a negative 6x here? I have to undo adding 6x. So I'm going to add positive 6x. Because I'm trying to undo adding negative 6x. Adding a negative is the same thing as subtracting. So to undo subtracting 6x, I'm going to add 6x. And I'm going to do that to the left side as well. And I'm going to combine it with the term that already has x's in it. So 3x plus 6x gives me 9x. I still have that plus 4. On the right side, these canceled out, so I'm left with just 41. 9x plus 4 equals 41. So then now I'm in step number 4. I'm solving it like I would a two-step equation. I'm getting rid of that addition by subtracting 4. 9x equals 37. From here, I got to get rid of this coefficient, so I'm going to divide by 9. And x is equal to, now you're probably thinking to yourself, 37 over 9, that doesn't come out to be a very nice number. So what you can do is you can leave it as 37 over 9. You don't have to do the division unless it says to in the problem. If the problem says round it to the nearest tenth, well, then I'm going to grab my calculator here and I'm going to go try to divide. I'm going to do 37 divided by 9, and it's 4.1 repeated. So what we could say is we could say it's approximately 4.1. So if it asks for a decimal, you can divide. If it asks for a fraction, you can leave it 37 over 9. If it asks for a mixed number, remember 9 goes into 36 4 times, and there's 1 left over. So 4 and 1/9. So you just kind of have to look to see what it wants as your answer when you're doing this final step here, when you're solving. So this is kind of a more difficult example. Hopefully you guys can get it to a point where you're just rearranging, getting it to a two-step problem and solving for there. This is kind of just like two halves to it. We got to do simplifying and rearranging here, and then 2 steps to solve it. All right? So you're going to have a Delta Math assignment where you're going to get a bunch of problems like this. You're going to have to use your T-chart, do it on paper, go through and solve it. Make sure you know how to do this for the quiz. Not only for the quiz, but we're going to use this all year long. This stuff just does not go away ever. So make sure that you have a good understanding of how to do this. Make sure you ask me questions if you don't understand.